All right, good morning or afternoon or evening or whatever time it is that you are taking these notes. For me, it is evening. And we are going to talk about factoring and expanding expressions. Now, when I think about factoring and expanding expressions, it makes me think that we aren't using this distributive property anymore. Not distributive property. We aren't using PEMDAS anymore. And that's because we are now using variables. So what we talked about with PEMDAS doesn't apply so much to this, and I'm going to show you why. So bear with me. The term that I want to use, I suppose, is expanding, which is making a problem longer. And you'll know what I mean once I start giving you the examples. It's also called distributing or distributive property. And the distributive property, as we know the word distribute. We have distributors in class. Distributors pass out things. So what we do with distributive property is we pass out the numbers. We make the problem longer by expanding it and passing out the numbers. And I will give you a definite example of what that means. Let me see if I can get a good definition for factoring. So we are going to be factoring expressions, and when we factor in expression, we look for the common factors to I'm going to say shrink an expression. I also call these are not, I promise you, these are not terms that are used by mathematicians. These are Miss Rio's terms. These ones, the shrink and the make longer, or whatever I'm going to use. I also call it undistribute. And so the terms that are used are expanding and factoring and distributive property. The way I make it make sense to myself and to students is using distributive property, making it longer, shrinking it, undistributing. Those are the terms that I use, so you can understand better. All right, so let me give you some examples first of each, and then hopefully you'll get a better idea of what it is. All right, so example 1 is asking us to expand or distribute. And the problem is 2r plus 8. And what that means is if we knew what r was and we were using PEMDAS, let's say r was 4, and we were using PEMDAS, we would say 4 plus 8 is 12, and 12 times 2 is 24. Okay, but we're not going to do that anymore. What we're going to do is we're going to use the distributive property. And what that means is what we do we have to multiply the inside by the outside. So you see my little arrows. Multiply the inside by the outside. Because we don't know what R is, we cannot solve this problem. But we are going to rewrite it by expanding it. So the first thing I'm going to do is multiply 2 times R, which gives me 2R. I move the sign down, which is a plus, and I multiply 2 times 8, which is 16. And now I have expanded the problem. I have used the distributive property to expand the problem. I cannot go any further because I do not know what R is. If they told us what R is, then I could possibly solve for the problem. All right, let me give you a second example. The reason why we start to do this is because you will be getting into problems that are much longer that you must factor and then eventually graph once you get into 8th grade algebra. So we start out kind of small and get a little bit bigger in 7th grade, and then by 8th grade you are factoring all kinds of things and then graphing them. Okay, so we start out with these kind of smaller problems in order to learn how to get to the harder problems in algebra. So again, 3 times k, and then 3 times 6, and I bring the plus sign down. So 3 times k is 3k. 3 times 6 is 18. I cannot go any further with the problem. Now these are equivalent. These are the same problem. Okay, but we have expanded it into this. All right, that is the basics of expanding. Now let me show you. I'm going to write expanding. Now I'm going to show you factoring. All right, factoring is when we have a problem already done, like 3k plus 18 or 2r plus 16. Now we're going to turn it into this version. So we're taking this and we're flipping it into this. And so when I factor, I always set up a little model, and what it looks like is here's my model, and what I know is that whatever goes here is going to be multiplied with what goes here, and whatever is here is going to be multiplied by whatever is here. So I set this up so I know. Okay. So let's give our first example. They want us to factor 2y plus 10. So what I need to do is I need to think what goes into 2 and 10. What are the factors? So I know that 2 times 1 is 2, and I know that 2 times 5 is 10. So what they have in common here is the 2. And because I know that they have the 2 in common, that's what's going to go on my outside. I know that this is a positive, so I'm going to move that positive here. I'm just going to move it on over. Okay? If it was a negative, I'd move the negative over. Alright, so next, remember, I'm trying to make 2y. So what has to go here to make 2y? Y. What goes here? 2 times what makes 10? 5. So there is my undistributed, my factored problem. 2y plus 5. This is our answer. And yes, they are the same problem, but they want us to know how to do it both ways. I'm going to give you an example where there is more than one answer. Let me find one that has more than one answer. Okay, we're going to do 6x minus 12. So let me set up my little, I already put my minus sign in because I know it's a minus, so I'm just going to leave that. Okay, what makes 6? 6 times 1, 2 times 3. What makes 12? 12 times 1, 2 times 6, 3 times 4. So, in common, I have a 6, I have a 3, and I have a 2. So we could have more than one answer for this. So we'll do them all. Alright, so if I put 6 on the outside, x goes in the inside. There's my 6x. 6 times what is 12? 2. Okay, there's my first answer. Now I'm going to put 2 on the outside. 2 times what is 6x? 2 times 3, and I have to have the x there to get 6x. 2 times 3x. I cannot add a 2 to a 3x because they're different. However, when I multiply, I can multiply a 2 times a 3. I can also divide a number and a variable. So I can multiply and divide a number and a variable. I just can't add or subtract a number and a variable, which is really important and different from what we were doing when we were combining like terms with addition and subtraction. Okay, so if 2 is on the outside, 2 times what gives me 12? 6. And then the last one I'm going to use is 3 on the outside. So 3 times 2x gives me 6x, and 3 times 4 gives me 12. So these could all be possible answers. There will be an occasion where you might have multiple answers. Just give one unless it asks for more. and it will be correct as long as you do them correctly. All right, so what I'm going to do is, I mean, and that's the basics of factoring and expanding. Let me do 2 more examples for you, and then I'll give you some problems to do on your own and check tomorrow. All right, so this one says factor 6z minus 9. So I'm going to set up, I'm going to put z inside. What is 6 and 9? What do they have in common? They have 3. So the common number goes on the outside. 3 times what is 6? 3 times what is 9? There's my factored version. Now remember, you have to have that z in there because there's a z here, or that variable. If I put the variable on the outside, then whatever's on the inside gets multiplied by that variable. So let me show you an incorrect example. If I were to put 3z on the outside and 2 and 3 on the inside, this would be 3z times 2, which is 6z, and 3z times negative 3, which would be negative 9z. And I would have I would have 2 z's here, and that would not be correct. So you have to know where your variable goes. Okay? If it gives you something like, and there can be an example where you do 4 minus 10z, for example, and the z is at the end. I'd have to put it over here. So 4 and 10 have 2 in common. 2 times 2 equals 4, and 2 times 5z equals 10z. So if the z goes second, or if the z is second in the equation, it has to be second in the factoring. All right, let's do one more expansion. Four times 4y minus 3. 4 times 4 is 16y. 4, I move my sign over. 4 times 3 is 12. This would be my expanded version. Okay, I want to emphasize one more time because I did mention it earlier. When I am combining like terms, like we did yesterday, you cannot combine a y plus a 1. These are different. Okay? You cannot combine a y minus, you can't say this is 1y, even though it is, there's only 1 here. Or you can't say it's 2y, I guess technically it would be 2y. This does not make sense. I cannot add y's and numbers. I cannot say this is negative 2y. They are not equal. However, we can multiply and divide y's with numbers. So, for example, if I did 4y over 4, that would simplify into 1y. Because 4 divided by 4 is 1. I could do 4y times 4, and that would give me 16y. These I can do. I can multiply and divide. I cannot add and subtract. Okay? That's very important for you to know and realize. Okay, so I'm going to write down your problems for today. And then tomorrow I will put the guide up for you to check your own work. All right, number 1, you are going to expand these problems. All right, for these next ones, you are going to tell whether W-H-E-T You're going to tell whether these are equivalent or not. So either you factor them or expand them and tell me if they are the same. (6x plus 5) and 6x plus 30. So your answer is going to be either yes, they are equivalent, or no, they are not equivalent. And 3 times y minus 6. Okay, and then I'm going to have you factor a couple problems, but I'm out of room, so I need to flip it over. These are factor. Oh, this one will be easy. Okay, that's it for all of your problems. Do them, and then tomorrow you'll check your work. And that's it for today. Let me know if you have any questions about this.